The ocean is never truly still. Even when its surface looks calm, motion is constantly unfolding, driven by wind, heat, gravity, and Earth's rotation. These invisible forces shape waves, currents, climates, and even life itself. So let's begin with the most familiar motion we see. Why does wind create waves? Air moves freely above the ocean. Water seems heavy and resistant, so why does wind manage to move the sea? The problem begins at the boundary between air and water. As wind blows across the surface, friction transfers energy downward. Small ripples form first. As wind continues, these ripples grow, allowing more surface area for the wind to push against. Energy builds wave by wave. The result is a chain reaction, where invisible air motion becomes visible water motion, turning wind into waves. That same wind can transform the ocean in much subtler ways. Why do monsoon winds change the color and clarity of the sea? The ocean can appear deep blue one season, then green or murky the next. Why? Monsoon winds don't just move air, they reshape the ocean surface. Strong seasonal winds stir surface waters and push them aside. This motion pulls deeper water upward. That deep water carries nutrients, sediments, and microscopic life. The result is water rich with plankton and particles, changing how light is absorbed and scattered, and transforming the ocean's color and clarity. But the ocean doesn't only respond to wind. It responds to heat on a planetary scale. Why does the ocean help regulate Earth's climate? Land heats quickly. The ocean warms slowly. Why does this difference matter? Water has a high heat capacity. It absorbs enormous amounts of heat without rapidly changing temperature. During warm periods, the ocean stores heat. During cooler periods, it releases that heat back into the atmosphere. Ocean currents then transport this energy across the globe. The result is a massive thermal buffer, softening temperature extremes and stabilizing Earth's climate over long timescales. One of the strongest examples of this heat transport flows through the Atlantic. Why does the Gulf Stream exist? Warm water moves north, cold water sinks south. Why does this current persist? The Gulf Stream begins in the tropics, where intense sunlight heats surface waters. Warm water expands, becomes less dense, and flows toward cooler regions. As it moves north, it loses heat to the atmosphere. The water cools, becomes denser, and sinks. Earth's rotation bends this flow, guiding it along a stable path. The result is a powerful current that delivers tropical heat to higher latitudes, warming regions that would otherwise be far colder. Yet not all parts of the ocean receive this warmth. Why are some ocean regions always cold? Sunlight reaches them, yet the water stays cold. Why? Cold regions are often fed by deep water rising to the surface. This deep water formed long ago in polar regions, where cold temperatures made it dense. Once sunk, it travels slowly through the global ocean circulation system. When it rises again, it brings cold temperatures back to the surface. The result is persistent cold zones, not because they lack sunlight, but because they are supplied by ancient cold water from the depths. That rising motion is a key process in ocean mechanics. Why can cold water rise from the deep ocean? Cold water is heavy. Warm water floats. So why does cold water ever move upward? Wind-driven surface currents can push warm water away from coastlines. When that surface water moves aside, deeper water must replace it. This process is called upwelling. The rising water is cold, dense, and rich in nutrients. The result is one of the most productive marine environments on Earth, supporting fisheries, ecosystems, and entire food webs. But even as water rises and falls, not everything moves with it. Why does seawater evaporate but salt stays behind? Sunlight heats the ocean. Water disappears into the air. Salt remains. Why? Evaporation only affects water molecules. When they gain enough energy, they escape into the atmosphere as vapor. Salt molecules are dissolved ions, bound within the liquid water and far too heavy to evaporate. The result is selective transfer. Fresh water rises into the air while salt accumulates in the ocean below. Over time, this process helps maintain the ocean's salinity balance. Yet not all water is equally healthy. Why do some parts of the ocean become dead zones with no oxygen? Life needs oxygen, yet entire regions lose it. Why? Dead zones form when excess nutrients enter the ocean, often from rivers. These nutrients trigger massive plankton blooms. When the plankton die, bacteria break them down, consuming oxygen in the process. If water circulation is weak, oxygen cannot be replenished. The result is suffocating conditions, where most marine life cannot survive. These conditions are closely linked to how ocean water is layered. Why is the ocean vertically stratified? Surface water is warm and light. Deep water is cold and heavy. Why don't they mix completely? Differences in temperature and salinity create density layers. Lighter water floats above denser water, forming stable stratification. Mixing requires energy, from wind, waves, or currents, and that energy is often insufficient to overcome the density barrier. The result is a layered ocean, with slow exchange between surface and deep waters. When this balance shifts, the consequences can be global. Why do El Niño and La Niña alter Earth's climate worldwide? Winds weaken or strengthen. The ocean rearranges itself. Why does this affect the entire planet? El Niño and La Niña are shifts in wind patterns across the Pacific Ocean. These shifts change how warm surface water is distributed. Warm water moving east alters atmospheric circulation. Cold water rising west reshapes weather patterns. The ocean and atmosphere act as a single, coupled system. The result is global climate disruption, affecting rainfall, temperatures, storms, and ecosystems across continents. The ocean is not just a body of water. It is a moving system, driven by physics, shaped by Earth, and deeply connected to life on land. Understanding how it moves is understanding how the planet breathes.